Hello, and welcome to our video series on high-end GNSS testing with the Rohde and Schwarz SMW200A. In this episode, we are going to have a look on interference simulations for GNSS receivers. Interference, unintentional or intentional, can significantly impair the reception of GNSS signals. In order to ensure that the receiver works as defined in the presence of unwanted signals, it needs to be thoroughly tested during development and production. In this video, I want to give an example on how to perform a multi-frequency GNSS simulation with multiple sources of interference. All we need for this is the Rohde and Schwarz SMW200A GNSS simulator. So let's get started. First, I'll put the SMW into the dedicated GNSS advanced mode to make it a little bit easier to work with. Going into the GNSS block and under Simulation Configuration, I see that GPS L1, L2 and L5 are already set up. I will leave the remaining parameters at its default values as well and start the simulation. As you can see in the overview, GPS L1 is provided on RFA. The GPS L2 and L5 signals are directed to RFB. The SMW is able to visualize the generated signals. This can be used as an indication whether the configuration is correct or not. We can display the power spectrum of GPS L1, which is provided at RFA, and also L2 and L5 signals on RFB. Now I will add some sources of interference to the simulation. Therefore, I use the internal noise generator, also called AWGN module. In the AWGN block, either continuous wave or short CW interferer and/or noise sources can be defined. Let us add some Gaussian white noise in the L1 frequency band. First, I define the system bandwidth of the system under test. Whereas low-cost receivers may have a front-end bandwidth of around 2 MHz, high-end receivers require a larger bandwidth, so I choose a value of 30 MHz. Next, we need to configure the noise power. We can insert this parameter as carrier-to-noise ratio. The carrier power displayed here is the average power of the L1 coarse acquisition signals of all GPS satellites combined. I choose the noise source to be 30 dB below the signal and switch it on. In the next step, I want to add an interfering CW signal in the L2 band. I switch to the L2 baseband and select a CW interferer. Let's say the interferer signal is not directly on L2, but shifted by 5 MHz. I enter the offset here. As carrier-to-interferer ratio, I choose a value of 25 dB and switch on the interferer. If we take a look on our power spectrum display, we now see the noise in the L1 band. And if we switch to the other display, we also see the CW interferer. In the GNSS advanced mode, up to 4 noise sources or CW interferers can be added to the GNSS signal. The interferer signals can be changed individually and also when the simulation is running. So this concludes our episode. You have seen how to add interference sources like AWGN or CW interferers to your GNSS simulation, how to change the parameters of the interference like power level, bandwidth or frequency offset, and how to monitor the signals. Check out our other application videos where we show more of the SMW's capabilities for high-end GNSS testing. Thank you for watching and see you next time.